So, question 1. We have this question with this division: x squared minus 6x minus 16 over x minus 8, and state the domain of f of x. So first of all, we've got to factor the top, and it's factors of negative 6 add up to negative 16, so it's actually x minus 8 times x plus 2, and we can still see straight away that x minus 8 is going to cancel out, and it does indeed. We get left with x plus 2, which we talked about before as a straight line. The domain of this, all real numbers, except x equals 8. And that comes from the original function, where we've got this x minus 8 equals 0. Question 2a. Now the second fraction here has already been flip-flopped from the question. You see that? So when we divide by a fraction, we multiply by its reciprocal. All we're going to do now is factor. So top left goes to x plus 1, x plus 3. That's easy enough. Bottom left, x plus 2 times x plus 2. If you're not sure about these, you're going to have to do some extra review of factoring. And then times top right, x plus 5, x plus 2. Factors that add up to 7 multiplied to 10 are 5 and 2. And the bottom, 15 and 8, so add to 8, multiply to 15x plus 3, x plus 5, and then we'll get the different coloured pen out, the red one out, and we'll cancel. So x plus 2 goes with x plus 2. We can cancel out diagonally, x plus 3 with x plus 3. X plus 5 with x plus 5, and your final answer is equals x plus 1 over x plus 2. 2b now. So common denominator is going to be x plus 1 times x minus 1. Put that on the bottom. Just like adding normal fractions. So we take this and divide by that. So we say x plus 1, x minus 1 divided by x plus 1 is x minus 1, this one on the right, multiplied by the top, and we get 2 times x minus 1. Minus sign comes down, and then we do x plus 1, x minus 1 divided by x minus 1, and that is x plus 1 times the top, and we get 3x times x plus 1. So now we have to multiply the top out, and we get 2x minus 2 minus 3x squared. Don't forget that this negative sign will multiply and change that plus sign. So it becomes negative 3x times 1, which is negative 3x, all over x plus 1, x minus 1. We don't have to multiply the bottom out. We can leave it as it is. But we do need to simplify the top. I'll put it here, so it's negative 3x squared, and of course we put it in order, and we've got 2x minus 3x, and that's going to be negative x, and I think there's negative 2 on its own, over x plus 1, x minus 1. And that's it, finished. That's the final answer. Question 2c. So you can already see the second fraction has been flipped, and what the question is, when we divide by a fraction, we multiply it by its reciprocal. So here we're just going to cancel off some numbers. We know that 9 goes into 36 4 times, and 4 goes into 28 7 times. So we've done the numbers. From here we can actually multiply the top out. So the top becomes 1 times 4 is 4. X squared times x, x cubed on top, so that's this one and that one, and then y times y is y squared, all over. On the bottom we've got a 1 times 7, 7, and then we've got x times x cubed, which is x to the 4th, and then we've just got y cubed on its own. So this final answer, the 4 and the 7 don't reduce any further, but x cubed over x to the fourth is going to be x on the bottom. So the 7's down there as well, and we've got x on the bottom. Then we've got y squared over y cubed. That's going to be y on the bottom. And the final answer is 4 over 7xy. So question 3 here says f of x is root x, and g of x equals negative root x plus 2. So the transformation from f of x to g of x is a shift 2 units left, and then this negative sign is a reflection in the x-axis. And we're given the point 3, root 3. And if you just check into this function up here, if x is 3, then y would be root 3. So the corresponding point on the graph g of x would be 2 units to the left. So we take the x value and go 2 units to the left, and we get 1. And then we take the negative sign will be multiplying the y value by negative 1 to give you a reflection that's downstairs on the x-axis, underneath the x-axis. Now, question 4. We know that f of x equals 2x squared minus 1, and g of x equals negative f bracket 1 plus x plus 2. So first of all, we need to start with this bit here, which is just finding out what this equals, so just on its own. So f of 1 plus x means going to function f and replacing the x with 1 plus x, and that will give us 2 bracket 1 plus x squared minus 1. So read it from the top. F of x is 2x squared minus 1, 2x squared, or 1 plus x squared minus 1. And we multiply this out. So 1 plus x squared is going to be 1 plus x times 1 plus x. We need to FOIL that out. We'll do that in a minute. And we do that first of all. So we get 1 plus 2x plus x squared. And there's brackets here, not a 1, minus 1. And that will give us 2 plus 4x plus 2x squared, and then minus 1 outside, and that whole thing is 2x squared, put it in the right order, plus 4x plus 1. And therefore g of x will be negative this whole thing, so basically negative 2x squared plus 4x plus 1. And at the top, and then plus 2. And that will equal, in full, negative 2x squared minus 4x, and then minus 1 plus 2 is plus 1. That's the final answer. Negative 2x squared minus 4x plus 1. Question 5, we've got g of x equals negative 2f bracket negative x minus 2 and then plus 4. And it gives us the point 4, 1 lies on fx. Well, we know first of all, if we deal with the f's, we've got a shift of 2 to the right. So that's going to go the x value right 2, and then a reflection in the y-axis. So all that means is we're going to shift the x value 2 to the right, and then multiply or divide by -1, whichever you want to do. So 2 to the right for x equals 4 will give you 6, and then multiply by -1 will give you -6. For the y values, first of all we're going to do this, which is a reflection in the x-axis, and then a times -2, a stretch vertically, factor 2. So the y value is going to be multiplied by 2 first of all, and then multiplied by -1 for the reflection. And then the final bit we've got to do is we're going to do the +4 at the end here, which means taking the y value up 4 units. The x value is completely unaffected, that stays at -6, and then we take -2 and we shift up 4 and we get +2 as the answer. And the final reflected point for the point 4, 1 is -6, 2. Question 6, find the inverse of the function f of x equals 4x minus 1 plus 2. And there we have 4x minus 1 over 2, so first rule is replace f of x with y. And we get that, interchange x and y, so we get 4y minus 1 over 2. And we're going to solve for y now, so cross multiply with the 2, we get 2x equals 4y minus 1. We're going to add 1 to both sides now. We'll take the 1 over, so we get 2x plus 1 equals 4y. Divide by the 4, and we get 2x plus 1 over 4, sorry it looks so messy, equals y. And therefore the inverse function f, -1 of x, equals 2x plus 1 all over 4. And question 6b, similar question, except we've got a bit more tricky problem here. 2 bracket x minus 1 squared plus 3. We know this is a, if we do the old visual side of this, the vertex is 1, 3. 1, 3 is about there, it goes upwards, so this graph looks like that. And we're going to find the reflection is probably going to look something like that, with the vertex being 3, 1, the opposite point. Let's work it out mathematically. So we replace f of x with y, and we get that. And we interchange x and y. And now we're going to solve for y. So take the 3 over, x minus 3 equals 2 bracket y minus 1 squared. Divide by 2. Y minus 1 squared still. Going to square root both sides, and when we square root we get this plus or minus, because the square root of a positive number could be plus or minus, especially when there's a variable involved. Take the 1 over, and y equals, put the 1 in front, plus or minus root x minus 3 over 2, and the inverse function f, -1 of x, equals 1 plus or minus root x minus 3 over 2. Very complicated, but because we know the reflection looks like that, it will be a graph that looks like that. Question 7, trick question obviously, because this is the way we looked at it in class like this. We're given that the inverse function is this, 4x plus k over 7. Of course we could go through and work out the proper function, but we know that the point 3, 1 lies on f of x. And that's there. That's given to us, so therefore the point that lies on the inverse must be that point switched around, which will be the point 1, 3. So if we substitute 1, 3 into the top equation here, into this one, we should get the value of k. So we know that y is 3 when x is 1. Over 7. Cross multiply, we get 21 equals 4 plus k, and k equals 17. Quite easy, really.